All right, so today we're continuing on with chapter 3, and our topic today is direct variation. We're going to write direct variation equations as well as graph them. So what is direct variation? Well, direct variation is a very special type of linear equation. So we can say that two variables, x and y, show direct variation, which is just a special relationship as long as it's in this equation here, y equals a times x, or we could say also it is often written as y equals k times x. Just different variables are used there. And as long as that variable that's in front of the x there is not 0, because that would cancel everything out. Now, I think it often makes people confused because they see this different variable being used here, but essentially it's the same thing if you wrote y equals mx. But they changed the variable from slope to a different variable just to indicate or remind you that it does have this extra special relationship because the x's and y's vary directly. And this only occurs when the b is 0. So essentially, we're just looking at slope-intercept equations or linear equations that have a slope and have a y-intercept of 0, or that b value of 0. So for example, because they always have to go through the origin, we know the b will always equal 0 for direct variation. So we could just write y equals mx, but to remind us that this is that special relationship that occurs, we change the variable to a k or an a or whatnot. And that just indicates that the slope has a little bit more going on. Not only is it the slope of the line, but it's also a direct variation between the x and the y. Now, if you have an equation written in standard form, similar to ax plus by equals c, and you see that your c value here is 0, this would tell you that this will be a direct variation equation as well, because when you go to get the y by itself, 0 divided by anything is 0, so you will end up with a b value of 0 there. If you do have some sort of a number there, then you'll end up with a b value something else other than 0, and then you'll know it's not direct variation. So you can determine whether or not it's direct variation, whether it's in slope-intercept form or in standard form. But in order to identify that constant of variation, which is basically your slope, you would need to have it in slope-intercept form. So basically, we're going to answer this first question. It says, tell whether the equation represents direct variation. If so, identify the constant of variation. So as I just showed you up here, since these are both in standard form, we would be looking for that c value. Since this one, the c value is 12, this would not be direct variation. So I can tell that just from looking at the equation. This one here has a 0, so I know that, yes, this is direct variation. Now, just to kind of take it a step further, now in the first one, we just wanted to know whether or not it was, and then we're kind of done from there. So even though I already know this one is not direct variation, I'm just going to show you how if we put it into that slope-intercept form, what it would look like. So if I did subtract 6x from either side here, I would have negative 3y equals negative 6x plus 12, divide everything by negative 3, which would leave me with my slope-intercept y equals 2x minus 4. So we can see that this is not direct variation because we have a b value of something other than 0. Now if we take a look at example b here, since this is a 0, I know it's going to be direct variation because when I add my x to the other side, I just have 5x, so 5x plus 0 is still 5x. And then when I divide by 2, I just have y equals 5 over 2x. There's no b value here. So essentially that's plus 0, right? So because my b equals 0, this would be direct variation. So let's practice a few of these. So first, we're going to tell whether the equation represents direct variation. So remember, if b equals 0, then the answer is yes. But if b does not equal 0, then your answer would be no. And then if you answer yes, then you're going to give me the constant of variation, which is your k value, which is really the slope of the equation. So for example, if we take a look at number 1, we know that yes, this would be direct variation because b equals 0. So therefore, the slope here, the slope is 8, right? That slope is a constant now. So the constant of variation would be 8. So number 2, this one we can see has a b value of 1. So no, this is not direct variation. Number 3, it's in standard form. We can already see that there's a number out here on the outside. So we know that that is not direct variation. Now, if I needed to go further with it, I could subtract my 3x to the other side. I would have y equals negative 3x plus 6. Again, I can still see that my b value is not 0, so this would not be direct variation. All right, and number 4, I see that I have a 0 here, so that tells me yes, this is direct variation. However, if I need to find my constant, I'm going to need to get this into slope-intercept form. So I'm going to subtract that 3x from either side. I have 5y equals negative 3x, dividing by 5. So y equals negative 3/5 x. This tells me that my constant of variation, which is the slope, but it's only the slope in a direct variation equation, is negative 3/5. Okay, number 5, this is in standard form, but I can see